Hi,
Hi, hi.
good morning, good afternoon.
Hi. I don't think we've met before, but good to
No,
nice to meet
should
you. I saw
introduce
you in
myself.
the Slack channel. Yeah.
Yeah, yeah. I don't know if we're doing a round of introductions later, or
We
we do
do
that
later.
informally
Don't worry.
later. Okay.
New faces, or at least one new face. That's good.
I think Benjamin is also coming, so it should be two faces.
New faces. That's great.
Give it a couple of minutes. Check. We are 1, 2, 3.
Hello, everyone.
Hello, hello.
Hello.
You're not yet in the agenda.
Oh, I made a peer, but forgot to create the create pull request button.
You're actually not allowed to talk until you're in the agenda. Sorry. So we have to cut this out of the YouTube now.
AI, please remove what I said.
Yeah.
Hello.
Was funny in the nullability work group. The video that was posted on YouTube was just a WhatsApp online screen. And I was like, wait, that's strange. And I checked the video and it was literally half a second. The WhatsApp was displayed on the screen in a 1 hour long meeting. And it's exactly what YouTube chose as a thumbnail.
Check. Do we have it? 10 participants. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, well, this should be fine, right? Quickly go. Pull requests. Probably merge conflict. No, it's merged. Okay. Awesome. Let's get started. Hi, everyone. Let me remind you that by being here, we all agree to the GraphQL spec membership agreements and to the GraphQL Foundation Code of Conduct. You can also read up on the agreements. They are linked to the agenda. And with that, let's start with a quick round of introduction. I'm Michael Stipe.
Hi, I'm Pascal. I'm Pakal today.
Oh,
You know, if you not do anything yourself.
Are you from Chill Cream?
Yeah, I'm Pakal. I'm Pakal from Chilton. Benjamin is not here, so let's continue with Tom.
Well, I
Yeah,
just joined.
Benjamin.
Sorry.
So, yeah, I just joined like a bit late. So yeah, I'm Benjamin. I'm from GraphBase. Yeah, and in Paris. Nice to meet you all.
You too.
Yeah.
I'm Tom, also from GraphBase, based in Berlin. Nice to meet you all.
I don't think Jeff is here yet. So I'm Martin, also from Apollo.
I'm Derek from Apollo.
Sachin from Apollo.
Camille from the guild.
Hi, I'm Steven of Netflix.
awesome.
And if you
So-
refresh, Shane from Apollo is on the page now.
Ah, yes.
Thank you.
Check. Oh, it's full today. Okay, so I went through issues on our spec repo and also cleaned a bit up the source schema chapters and generated from that a bit the agenda for today. So I have 3 items. There's a 4th item we can talk about if we have more time on this. The first one is one that Stephen actually tried to get into the agenda a couple of times. It's about the key directive, if it's feasible to have a simplified version of it. We can have a look at that. That is on the spec repo issue 168. Then I had a discussion with Kamil around relay specification node interfaces. This is also an issue actually on the spec repo. It's 178. It's also something that I think Chain initially put on the spec repo because Apollo also is implementing that or is trying to solve that. So we can also discuss this issue. Then there is another thing around batching that was picked up by GraphBase and is around if we could allow batch lookups in cases where you don't have requirements on an entity on a subgraph. That's for them in the case of if this is not actually really GraphQL, but gRPC or REST, basically the connector stuff. So we can also talk about that. Then there's a fourth thing. I don't know if it fits in because I have started writing a more abstract chapter in the specification about entity types and value types to put that more in perspective, because we are talking about a lot about entities in the specification, keys and stuff like that, but we don't have like a more abstract explanation of these terms and what they mean to us. So we can also talk about that if there's time. Does anybody else has a topic? No, so we can jump into the first one, I think, and that is the
keys.
Yes,
I'll
and
present present that one.
yeah. Wait, I'm just putting it on the. It's this one, but it's originally actually on the working group. Is it this one? I think you introduced it actually. But
It's this one. I just copied it from that 440 in the working group. We closed that one and moved it here.
Yeah. Awesome. You want to take it away?
Sure. Yeah. Mind if I take the screen share?
Yes, you can also share it. Sorry. Yeah.
There we go. Okay, so the gist of this proposal is to use a simpler definition for a key, and this is, you know, maybe if we were starting from scratch, this is you know, maybe where we would have started from, you know, kind of the, you know, the most obvious approach, but we're starting from a successful federation you know, definition implementation that exists where we have multiple fields that you know, both multiple in the sense of complex keys and in the sense of alternate keys. But the main thing that I'm thinking of right here is the complex key scenario, and as powerful as that is, it does add some complexity to implementation. And so the purpose of this proposal was to just consider the, you know, what would it look like if we stripped back to a simpler object instance identity system. And so that's basically it. There's, you know, there's different ways syntactically this could look. We could, you know, like here we just have key directive on a field, or there's like the node approach of like you have an interface that defines a key field that you have to have. But so, some of the, you know, some of the areas this would simplify are you know, notably the contract talking to subgraphs and like the batch lookup, which you know, there's just some discussion about, and so this would work with GraphQL transport as it exists today. It wouldn't require changes to be able to do batch GraphQL calls or batch variables. And then another thing to note is that I think this could be.
I think that's actually orthogonal, right? Because that the reason for that is the support for requires. So you would still need that even with a single key value. Like, so
Yes.
that's unrelated.
Yeah, I guess yes. So in order to not have the batch lookup, we would need to strip back both requires and complex keys.
Yeah.
Or have requires be a kind of a v 1.1 feature that isn't part of the.
I think that also hooks into the
core
discussion
spec.
that GraphBase started on our Slack channel. So we might be able to
Yeah.
connect the two threads later on because it sort of points
Yeah.
to a minimal version or a mini version.
Yeah, it is kind of timely there. And so then the one other thing I want to point out is that the big question here is, I think, around existing. I mean, beyond the spec itself is the existing subgraphs and existing usage of federation, and how we could accommodate that. And that's a big concern for me personally. We have where I work, we have hundreds of subgraphs that my team is kind of responsible for shepherding. And so I think that we could do this with tooling on the subgraph side. And basically, you can locally in your subgraph SDL define multiple keys, but then those get serialized to a single key and implemented across the wire between the gateway and the subgraph as a single key field.
I think that part would work, but as part of evolution, we also have to be able to deal with existing subgraphs, or at least like specify under what circumstances we wouldn't for this spec.
Like existing subgraphs, like without
but that do use
without modification,
multiple keys, or
yeah. I guess my thought with like existing subgraphs, like being able to accommodate in the same federated graph without modification, would be that a realistic gateway implementation would need to accommodate just Fed2 verbatim as exists today, like with the entities resolver and everything. So I think of that as kind of outside of scope.
So those would be the two different modes. So that would be, yeah.
So just to understand right, that's basically you can omit the key directive, right? And it would be inferred from the schema because it's known, for instance, that foo implements node or whatever, and that ID in this case is the key.
Yeah. Maybe to clarify, so one of the underlying reasons for supporting multiple keys, and something that isn't really addressed by a proposal like this, which isn't to say that we shouldn't define this as a version of lookups, but if you start from the idea that multiple systems in like your entire organization have different key requirements or the ability to support different types of keys for the same, but conceptually the same entity, you do need a way to signal to the query planner which type of key is expected by which subgraph. You can't just like have one opaque ID because you need to know like which subgraph you're sending it to and if it's actually able to interpret that. Like the classic example that we've been using that isn't realistic, but like you have your product by UPC or by SKU. Like one system is able to deal with like products from one perspective, the other deals with them from another perspective, but you still want to bring them together into one entity. You need to be able to map between those different ways of identifying what is conceptually the same entity. But that's definitely a more complex scenario. So I mean, it might be fine to support to specify sort of different modes, but it is something that we know people are using.
So this would be the case of like, as opposed to complex keys, this would be the case of like multiple keys,
Yeah.
I guess, where
Yeah.
like, yeah, one system knows it by this key, one system knows it by another key. There's got to be at least one system that knows it by both keys, I guess. And so that, yeah, we could still, I think, one thing we could still accommodate with this is that concept, either by the key directive directly on a field, but allowing that multiple times. And so when you have multiple keys, it means that the service can accept any of those.
But
it
then
still only needs one of
yeah.
them.
I think I have two concerns with that. I think one is that it's easy to confuse the case of like complex keys and multiple keys. Like if you put like a key directive on two fields, does that mean that like those fields together define a key, or that you can use them independently? And also, if you encode everything into a single scalar value, which I really like, by the way, but then it now becomes like opaque, like what information is actually carried in that value. So it's not as easy to track down sort of what goes wrong when a system isn't able to interpret a key. Right now, you can just say like the schema doesn't define the skew field on product, but now it's sort of something that happens as part of the implementation, like interpreting that scalar value.
Eric?
Yeah, I personally do think that in the vast majority of cases, people should use simple ID field for a key. It makes their life simple, but reality is there are use cases where you may need to have separate ones, as Martin said. And by limiting this design to actually follow this approach of a single key, I think it simplifies some of the things, but also makes it much harder to reason about for the users as well. If there's some stuff auto-generated behind the scenes, I think it's actually gets more complex for folks to reason about how I think about my book with ISBN or UPC or ID. And I think the goal of this is actually to make it simple to adopt and simple to reason about. And from that perspective, I would say it complicates things of auto-generating things.
So just one thing here. We have put an explicit note into the spec is that you can put in your implementation in inference like this in front of the specification. It's a post-processing of the subgraph schemas. It's a pre-processing of the subgraph schemas. We do that, for instance, for Fusion 1. So to be compatible with Fusion 1, where we infer basically from the lookups the keys. And where we also don't have a concept like shareable, because we are shareable by default. So you can take a legacy schema, if you will, and then pre-process it and then put it into the composite schema composition. So you could create a design where you don't need keys and they are inferred. So there's nothing that stops a implementation of the specification to have such a pre-processing. The second thing, I think what we have to consider if we want to have that is if you want to have. Can you show the issue again? Yeah, the second thing, if you scroll up, is if we want to allow the key directive without any parameters on ID to be the same as if you put the key on the type that references the same field.
But you mean without changing the lookup mechanism? Like we'd still be relying on lookups. It would just be a different way of specifying the key. I think as a shorthand, it makes sense at first, but then my worry is that it quickly breaks down because like if you then want to put a key directive on another field, we either disallow that, so you have to go now you have two styles that you sort of have to keep track of, or it gets confusing because we're confusing multiple and composite keys.
Yeah, so composite keys
gets even worse. It gets even worse when, let's say we would have a validation rule that you can actually only mark one field as key. Think about the OR case. Type foo implements node. There's no key on it, but you're also not allowed to add one because node has ID marked as a key.
Yeah, and
like the rule that people that devs have in their head is that you're only allowed to add one add key per type, but you're actually not allowed to add one add key per type because node implicitly implements the key already on this interface.
Yeah, your point being that if we allowed automatically inferring it, then we need some build flag to opt out of that, and like people don't there'd be things that would be like automatically happen. It'd be different per implementation.
Yeah.
So
but what still works, and we don't have to change the specification for it. You could put all of this in a preprocessor. Like, well, you could actually pick up the keys without arguments and then put them on the type level. I'm just saying, if you want this functionality, you could build it.
But I think what Stephen was getting at is not just like a syntactic convenience, but a simplification of the spec, including perhaps query planning, by letting go of require and support for multiple and composite keys, and that is attractive, I think, to
exactly.
So if we can somehow tie this in with sort of what the node interface has been trying to do, like the relay style lookups, like if we have one predefined lookup mechanism, that's sort of the minimal way for a subgraph to hook into the system without support for any of the additional functionality that you may not need. I think that would be something that's really nice if at least it sort of flows out of what we specify here.
But doesn't that work also? Like, if you think about it, because we can annotate, like we can define node as a lookup.
Well, I think the thing that complicates this is that that ID is supposed to be sort of globally unique across types, and you still need to, and it's an opaque value, but you need to be able to interpret it at the router level, or so if we can. I think we have to standardize that part as well to make this truly interoperable.
Well, it's just
yes, that's actually also the discussion today. So these three topics actually fit very well together because it all ties into that.
I have a question regarding the key before we move on to the next one. What is the prime use case in your like? Not a demo use case like the product with the ID and the SKU. Like what do you see people do with multiple keys? Is it? I think a big part of it is probably sharing data across services, and they're more or less abusing keys for this feature, right?
That definitely happens, and that's what we're hoping like require will take over and context to a certain extent. But I mean, and Shane might have some, and Derek might have some, and Sachin as well might have some more sort of use cases, real world use cases. But in general, sort of in large organizations, like systems have different ways of identifying entities. Like there are legacy systems with different types of IDs. There are other systems you're trying to hook onto, like bring onto the graph, that have their own way of identifying what you really want to be the same entity.
I mean, what I've seen is that there is the prime example is you have some user management system, Azure AD or whatever, which has a key. You have an internal key in your management, and then you have some legacy system which has some I don't know, employee ID, which is it's just a six-figure number that you have. That was the prime example for it. But is this like, how often does this happen? Like, is this a one?
From what I've seen, there's tons of folks using composite keys.
And multiple keys.
And multiple keys. There's tons of both of those. It's not rare.
Yeah. Okay.
Same.
Yeah, and within our just examples within our own graph, there's well, both cases of alternate, I'll call it alternate keys and complex keys. Alternate keys, I think we could accommodate without having complex keys. Maybe not using the interface, but like using the at key directive on a field, we could say, okay, this, I'll accept either this key or this key, but still that means that over the wire, there only has to be a way to send a single key. It's just, it could be either depending on the query plan. And for the complex keys, the use cases I see are where, like in their database, they have there's not a single primary key field. There's multiple fields that together are unique, the only unique way to identify. And so the service is basically exposing their database, exposing their data, abstraction in their API, as opposed to creating an ID abstraction that is, the composite of the fields that create the key. And so I think that this isn't as much about like restricting what's possible to express, but enforcing a layer of abstraction at the service boundary there, where the service, whatever goes into their unique key, they expose as a single key. Very similar to like the way that the node, the relay node interface, forces that abstraction. And so often the key is the ID field is synthetic, and like a encoded form of something else.
So when we put them in order, would we agree on that most entities are identified by the ID or a single key? Many entities, or it happens quite often that you have alternating keys, and then there's some where you actually have a complex key, excluding the scenario where you abuse keys to actually transport data from one server.
I think that's more common than you think. Not just the abusing keys, but also like disambiguating a key, like having like an organization ID and a user ID, or.
Boom. Then you have two identifiers. You're right. Yeah. Okay.
Yeah.
So
it depends a bit on how you design the whole system, if you need that or not. So let's maybe move from this topic to the next one with the nodes. They all tie in. And maybe Shane, do you wanna, because you opened it? It's I can also, but if you wanna take over, I'm fine.
Yeah, I'm pretty sure I opened this just in general because we keep coming back to this over many of our meetings. I put the link in the chat, but quite simply, we keep talking about the keys in terms of the subgraphs and defining them, but there's one part of the node relay spec which says that there's this globally top level query.node lookup resolver, right? Which in Federation, the way that we say is that every lookup or every field at the top level actually only exists at one subgraph, one service, right? Unless we do shareable, but let's ignore shareable for a second, but we'll probably come back to it. But this in the relay spec says that anyone can enter here and say, I have this key, go fetch data across for that key across all the services. And this works really well when you have this monolith style, of course, right? Because you can say, here's the key, go fetch all the services, right? You have all the services in that single monolith deployment. But in Federation, we have this root entry point. Like the question is like, what subgraph would be responsible for resolving this, right? Does that mean the query planner and router has to like just know, like have to resolve all these things and then route to the subgraphs? There's examples from Wayfair that they spoke at GraphQL Summit about. They actually do this. They have like an internal mapping in the router that says like, okay, give me your node key, and then I actually convert that into an entity key, and then that entity key is then the one that I just go and look up on all the subgraphs. So, but the question here is like, do we just need to acknowledge in our spec that like that this technically is still not supported, because you can't really put at lookup on query.node in relay and only have it exist in like one subgraph, because like you'd also need to indicate then that this subgraph can only return like these nodes, so you can only go here for these lookups, or you have to go to somewhere else for these lookups. So like this requires more syntax and all this stuff. So like I don't know if we just need to like clarify that like, yeah, this isn't, Federation is still not technically compatible with, and Composite Schemas spec is still not compatible. Like it's probably worth commenting, since it's gonna be a question from their users.
So I don't think it's not like what we do in Fusion is actually we don't have a centralized node resolver subgraph. We actually have them, like each subgraph has a node field, and this node field, like on this subgraph implements node for the entities it can serve. You still need like a general function on the gateway that can like look up what entity a type is, right? So you can route it then to the right subgraph to use the right node field on the right subgraph.
So that doesn't mean you need to standardize on the format. It can be an opaque identifier, right?
It can be opaque, and you don't have to standardize it, because it depends on how you build your gateway. That's why I say it's a bit also an implementation detail. Like if you give users a hook in your gateway to just provide you a method to essentially look up the type from a key, then you could use ID ranges like Facebook does it, or you could even have a lookup table in a database if you want to build that, or you could just decode the ID strings. But in your system, you have to have a knowledge about how these IDs work, and they need to be standardized in your system.
Yeah, that's I agree. Like that you could build that system in combination with Federation, but it's very much we have to like, I think we need to like at least have a comment in the spec or somewhere on there that like this system is not going to work out of the box with the relay, the spec, because like you have to go do all that extra work. You can make it work, but like it's not something like you can just say add query.node and like you put it on one subgraph and like that's gonna work, because like that.
Yeah, but that's what I mean with an implementation detail. You could, like what we do in Fusion, we basically say if you use this ID format, it just works out of the box, right? You can just build it and it works.
But would it be worth like trying to standardize even as a recommendation an ID format as part of this spec?
That we could actually, yeah, that would, yeah. If
I would
Martin,
say,
that's actually
I would say it's only worth an editorial note that an ID format could be type name,
yeah,
whatever. But like the ID formats are really like we changed it once because we like you can.
No, we aligned with what actually everybody else was doing, Pascal. We were doing it differently, but you could say in the specification, like that we assume that this is the ID format, and in this case, it just works with the gateways. We could specify something like this, or we could recommend that, or do an appendix, even like an appendix specification that specifies this part, and it's optional to implement. But then you have a bigger chance that this will work with more gateways.
So what I think is that somewhere in this node interface discussion that we have is a generalizable pattern that we just don't know about yet. There is some way that you could express like the use case of having a node, which is an entity resolver, which is a lookup, which is spread across different services, which is identified by some method. I don't know, whatever the rules will be for this feature. I have the feeling that there is a generalizable way to add this so that it's not a special case how you use Node, that it could just be part of the specification. I don't think it should be part of specification V1 because we have no idea how this pattern will look like. But I would also say that having support specifically in the first version just for Node would be fantastic, because it would solve a lot of problems that you have. Like many entities are identified by a simple ID, right? With this, you already have a resolver for many entities in your graph.
Well, the problem is that most existing entities do not have a globally unique ID. They have an ID that's specific to their type, unless they already support the node interface. But I mean,
yeah, that's the thing. That's the thing. Like that's the thing. Like it's specifically node interface, relay pattern node interface, where you have an ID which is which for the client at least is completely opaque, and which may have meta information what the type, like with the type encoded into it. And technically, if you take I just call it the default format now, you have the type name and then you have the value of the ID, with just a little hint to the gateway knows where this type belongs. It's not much that the gateway needs to know in query planning to decide where this goes.
No, it's not query planning. The query plan has to actually cover for all the cases, because that's a runtime value.
In execution.
Yeah.
But yeah. So
yes, Stephen?
Even if we don't have a pattern, it would be nice if we like have it as the playground, right?
Stephen?
Putting on mute. So I agree that this would be, I think it would be really great if this could be addressed somehow, even if it is minimally just as an appendix in the spec, because the node interface is, from the beginning, this was introduced, very, very shortly after GraphQL itself, and it's solving the object instance identity problem, right? Like, in a GraphQL API, I don't want a product, I want this product. And this is a very useful thing that any client needs. The relay client standardized with this this node interface, but any normalizing client needs a way to do this, to look things up in a cache in the graph. And the node interface has always been kind of this quasi spec that's kind of unofficially like a GraphQL spec thing, but not entirely, and it's been kind of ambiguous. And I think it is it's so it's filling in a gap in the GraphQL spec. And Federation also, I think that one of the key challenges with the Federation is the object instance identity problem, because you need to ask subgraphs about this specific product, and I need to fill in these fields. It's the same problem fundamentally that we're solving with like the entities union and the entities lookup. And so if there was one outcome from a composite schema discussion at the GraphQL working group level, like we're doing here, it would be amazing if we could unify this somehow, like a standard GraphQL way to do object instance identity, and have that kind of like as a core thing that we can standardize on, whether that is the node interface itself, or whether it is something else, but that is compatible, with node interface. And since node interface exists already, minimally, I think it's an elephant in the room that we need to address and have a good story for how it can be compatible. There we go.
So
Derek?
I would echo that. Yeah, it would be great if we had better support for it. It is solving the problem that folks are needing for like global identification of objects, right? Entities they do kind of solve the same problem. It's more on the granular, so hitting the single node interface versus specific product. But technically, within your client, you already know I have a product, I need to refresh the cache, so I can just fetch that product. You could do that. So technically, it's it still works. That being said, right, again, I think having a better interop would be great. I don't think it should be in the V1 of the spec, because it actually does complicate things, right? So there was a comment whether it should be in the query planner or not. I think it's actually the translation probably should happen before the query planner. And the reason I'm saying that is that in the naive approach, if let's say you have 100 subgraphs that implement the node interface, right? And if you have to plan the 100 subgraphs for potential paths to each one of your hundreds of different entities, in the naive approach, your potential query plan could blow up.
Well, you can still restrict it by type condition, right?
Yeah.
In the query, you're still
Exactly.
But I'm saying it's like because I've seen that actually happening in real subgraphs implementations. It can cause the queries that to take very, very long times to plan. It can cause issues that we cannot actually plan the queries if they're actually people are not careful how they write those queries, because the complexity could be like potentially millions of permutations of potential query plan that's basically never plans, right? So yes, there are ways to address it, but I think there's actually a lot of nuance of how this would be addressed. That's why I would say we should punt it later on, how we would like to tackle it. But it is something that we should keep in mind and have a better interrupt story in the future.
Yeah, just from the query plan. So what we do in Fusion is we just plan what type conditions you have. And if the ID turns to be out at runtime to be outside of the type condition, we just do a lookup for the two properties, ID and type name, at the subgraph dynamically. That's just the fallback case, and you don't need to plan a lot for it, right?
Yeah, it implies the user write a query with the type condition that they want to restrict it to the types, and this
you
is
must otherwise you just get two properties back.
the ID and a type name. Yeah.
Yeah, and this is very cheap to look up, even without enhanced planning. So what we basically do is we only plan for what we have type conditions, and if the ID turns out not to be in these cases that we have type conditions for, we just quickly look up the graph that has a node field for the type that is in the ID, and then we send a request for these two properties to this subgraph as a fallback.
Totally get it. But I've seen some queries that actually are causing this to blow up because the type conditions are not specified direct on the proper level, because there are some common node fields that are actually across hundreds of different subgraphs and hundreds of different implementations.
Yeah, but you need to know like
yeah.
like the node interface by definition is just an ID. So you need, if you're just interested in the ID,
I understand that, but that is generally tied to some other interface that has that node interface plus some other common fields on it. So
yeah, I know
the one that I was thinking there was a use case that was actually done, and by actually asking folks to specify type condition in their queries, it made them so much faster and so much better. But originally they were including the common fields from the common things together, which was causing a complexity through the roof, basically. So I'm saying you got to be careful on those, because people will miss some of those assumptions there, how they do those. And writing the queries, there are ways to actually simplify the query planning process by providing this additional type condition information, but you have to be aware of those, and the users often do not.
I see. You mean the multi inheritance? You actually need. Then you run into. I can see that.
But that is
company. No. I mean, look. A company deciding that the ID on the node is actually not enough. All our entities in our domain.
No. It's not enough. So you have the top level entry, kind of like a lookup or node thing, right? But that returns you a common interface of things that every object in my company has, right? So I have some other things, and one of them is the ID, which matches the node ID. And now you have this common object across hundreds of subgraphs with a couple hundred of different entity types. And now, like when you're writing a query, well, I'm looking this query, select common fields. Sounds reasonable, right? And then I do select specific ones on a specific types, but that has real implications on the query plans. And so what I'm saying, like, you gotta be careful what you're doing over there, because it's possible to shoot yourself.
Yeah, but my argument there would be that you have this problem anyway, right? as soon as you have a high-level abstraction, you have it on any field that returns an abstract type that
Yes,
has a
that's
high.
that's totally true. That's a valid comment. It was basically that, but that was kind of exacerbated by the node usage, because that's how the pattern was actually being. And it obviously started with something small, but the supergraph grew and grew and grew, right? So it's kind of like eventually it got to the point that it became problematic.
So
Yeah,
build-
what the beauty is, if you have the node interface and stuff like that, and we just make this possible, is then that's like the entry level into a distributed system with GraphQL is so much easier. In your subgraph, you just implement the node for the nodes that you have. You put them together, they compose automatically for a very simplified experience, right? And the system just works. There's no directives, nothing, and it just works out. Stephen?
I was just clarifying that in that situation that you're describing, Derek, it's not the node interface itself, though, right? It's like something inspired by that that's grown a bunch of other fields. Is that right? Okay. Yeah.
Yep.
I mean,
Yeah, I've seen that too.
Classic thing I have in mind is like the version. Like the decision of it was that the every entity has a version. Now you have an interface which is implemented by everything. Now update the version in the UI, and now you have a query, and you essentially have the whole domain as an option. But technically, this could still be a non-issue if the planner is smart enough to deal with these interfaces. Like, let's say this is an interface which is known to be on any graph. You don't have to simplify it. Like, you could, if the planner doesn't calculate all the permutations, it just uses the interface, then you wouldn't have the problem, right? It's still just a switch case. Like, it's this node lives on, it's this type lives on this service. I just sent the request with the interface.
So,
Technically.
bringing it back to our spec then.
Yeah.
Since we have to define, our goal is still to define some naive query planner algorithm. Do we need to include this query node relay pattern in that naive query planner algorithm? Or is this going to go into an external appendix?
Yeah, that's a good question. Sure, like, is this part of the main spec, or should we just opt to have it as an appendix?
So
What is
maybe
the
in the
feeling?
spec, but not the query planner, if so.
But we need to specify certain things around this. Like, either we say, okay, it's in the spec, it's this ID format, or we specify that a gateway must have a hook for this, things like that.
Yeah, I really like the idea of, I think that was what Stephen was suggesting, like an automatic mapping between keys and an ID format. So if we have a generic format that is not just entity name and ID field, but has the ability to encode multiple fields in a standardized format, then we could automatically map that to key directives. So we would still know sort of which subgraphs support which fields. But in the simple case, it would really make things easier for people to get started with.
Yeah.
But we do need a standardized encoding format then. And I do think it can be as simple as like entity name and an encoding of like a set of fields that is specified through the existing key mechanism.
So
Eric?
my question is, going back to the original thing, is we all think that it would be great to have this interrupt. We all think that it would be very, very nice, right? The question is that actually a pre-requirement to have the very first version of the spec? Because we've been working on it for quite a while, right?
I wouldn't
There's still some ways to
say
go.
so. I wouldn't
tie it to version 1 of the spec. Eventually, I would add it in. It's just basically because it's growing the scope of the spec as
I would.
Yeah.
I
Maybe to preempt the discussion that like the next point on the agenda, there's also a case to be made for this to be sort of a simplified version of the spec where you don't have to implement the full mechanism, but you may be able to get away with just supporting this ID mechanism.
Yeah, and like we are still in stage 0, right? From the spec. So we can at some point define now we do a cut, because it doesn't mean that we stop on the other areas. That's also would be a question from today if anybody wants to pick up exploration around maybe the ID format and stuff. So this can run parallel to the work that we anyway do on the spec, and then we decide does it go into the spec or not. Does it make sense?
Yeah.
Okay.
I mean, it would also be completely fine to have this as an have nothing or have it as an appendix or an RFC or whatever. It's just it would be like we all agree it would be fantastic to have something like this. So I think we should like have it in our heads. If someone has a good idea, there needs to be a place where we can put this, right?
Yeah, let's go to the third topic, that is batching. I'm just going back to the batching issues that we actually had, because like Bernard commented on that. And that's actually what I think, Martin, if you remember, we discussed that in the very beginning. That was one of the things we had to overcome.
Yeah, and I do think, and this is again also getting back to what Stephen was saying, like the reason we ended up here is because we felt there was a need to support complex requirements that people currently are using, and in particular required fields. And I still think that's something that like the spec will need to support that.
Yes.
But if you can specify a version or a mode of the spec that basically disallows that, and maybe on a per subgraph basis, then that could greatly simplify the mechanism.
Exactly, and I also thought, what if it's really on a per subgraph base? You say this subgraph will not have any requirements.
Yeah, exactly.
And then batch lookups there would be fine. And that you could decide in your system, maybe at the beginning, to say, I don't want any on any subgraphs requirements. And if that's the case, also the planning algorithm could do a much simpler job, right? So there's an opt-in that you can say, I don't care about requirements. Maybe today, tomorrow I do, and then you could introduce it per subgraph. Because then, like products, something like this would be IDs would work out. As long as there's no field on product that has any requirements.
Yeah, or any other field in the same subgraph that you might end up requesting. Yeah.
Yes, but for these kinds, it's fine. And I think if you because
it has other downsides, right? Like it doesn't support like streaming and
yes. And the variable batching, I think, is because of these things a lot more flexible, because we can stream, we can also request batching, use a combination of request batching and variable batching. But like this could open a way for things where you actually map REST underneath. I don't think we need to tackle this in the spec specifically, but I think by allowing such lookups here, if there is no requirement possible, and we would need to have validation rules that make sure of that.
Yeah. I mean, we do need to probably be explicit here about the fact that it's batching.
How do you want, like,
I mean, I feel a bit bad about sort of automatically deriving that from the fact that it's an array value. That seems too magical. Something like this, yeah, or a separate directive,
Batch lookup.
or yeah.
But is there any ambiguity about like without that would inference be ambiguous? Like would there be such thing as a
I don't think it's ambiguous,
array
but I think
singular?
an array key, yeah.
It would. The response is the identifier as the indicator, right? That you return an array of products, because otherwise it could just be the key.
Yeah.
Yeah, because in
We
the
would have
we
a
just
field on product, which is IDs, which is an array, which is the identifier, the actual key of this system, of this product. But by returning an array, you indicate that you actually expect more than one lookup, more than one result.
Well, but you have to validate that you have the same, the IDs also, like the array, and because it's
Yeah.
like, what if I have, well, what should be the behavior? I specify 5 different IDs and only 4 of them return something, right? Do I return empty there, or do I return 4? And
Yeah,
also,
we'll need to
like,
specify that. Yeah.
you
Yeah.
have to specify all of those things, right?
so
And what if I just
yeah.
press 1, right? And it's
Be-
not an array of IDs, just IDs.
Before we go too deep into batch lookups, I think the initial question was about indication of how the subgraph should show that what it supports and not. So maybe we should talk about that part first, and then we can later like iterate on what actually should be supported and what not.
Yeah.
Can
I
you
think
put
we're
the-
running out of time as it stands.
Oh, we have 3 minutes, then must
Yeah.
be enough.
Can you put
Yes,
the current one next to it? Like what is allowed today?
Yeah, so that I wanted to say. We specifically throw a validation error if you return a list.
Yeah.
Just so we kind of at the moment would disallow. We would disallow this one, right? And what we allow today is this.
We also allow the other one.
Which one?
IDs with an array, but returns just a product.
No, yeah, kind.
We do.
I mean, technically,
yeah, you're right. You're right.
Product
technically, the array is then like a single identifier. Yeah.
Exactly. Yeah. Technically. Yeah, this looks good.
If we're not allowing like in the initial case where we don't allow an array returned, should we also disallow an array key just to
No, because like the like let's say your key field for whatever reason is an array of IDs on the product, then this would technically be allowed. So
what if we just say that's not allowed?
Well, but it is.
yeah, no, the problem is this kind of has a problem, because if that is your data type, we suddenly say you cannot use it. We force you into the structure. Like I would, but this is not
sure. But how common is the use of an array value as an identifier?
I don't know.
It seems like this is a user error that we may actually want to flag, especially if we do end up supporting like both cases, because then you get weird like mixed scenarios.
Well, there isn't any mix. Like at least from graph-based perspective, what we do is we detect whether it's batch lookup or not only with output type. If it's a list, it's batch. If it's not a list, it's not a batch. So if the ID was a list and it's a batch lookup, we would expect a list of list.
Yeah, and also in this case, I think you would need to have an is specifier to make it clear that IDs would. Yeah,
we don't. At least we do the same thing. We just expected then the key to be in a list. So if the key is a list, then we just expect it to be have an additional wrapping.
Yeah, I think that.
And the mapping with lookup, we do it the same way, whether it's batch or not. And that's probably one of the most complex things that we had to implement. And partially because there's so many different keys and like possibilities of auto detection, like is a mix, and so everything that, so yeah. But detecting the batching here is pretty easy. It's just the output type.
Yeah, but you still, like in your case, obviously you support the like the subgraph implementation you control, right?
Yeah.
But in the general case, we need to specify more about the expectations here, like how the IDs that you pass in match up to the output. Like ordering
Yeah.
is sort of implicitly assumed to be like the same, but that's not specified anywhere. We have to specify how to deal with null values. So maybe you only allow
but
it
then
when
it's the
when you have the
same-
ability to refer null values.
It's the same problem with Apollo Federation returning a list of entities, and the same problem with variable batching. Like variable batching, if suddenly one of the entities is null, it's I'm not sure to see how batch lookup is different from those two other cases.
Oh,
If you have one null entity,
Well, I
you
mean, in
handle
those
it.
two other cases, there are there are existing patterns for how we do that. Like the client and the server have standardized sort of what they expect out of
But
that.
how is it different than from here? You just reuse the same patterns, no?
No, but the problem is you could implement your subgraph in different ways. Like you're free to implement this resolver in any way you'd like. So you could even return like the products in alphabetic order. Like that
okay,
semantics.
I see what you
those
mean.
those semantics are not implied by the schema.
Exactly.
So we'd have to like make them part of the standard.
Any subgraphs that we give you that follows the spec, you would need to understand.
Yeah.
In this case, you have both in your own hand. That's why you can align the semantics that you expect. But you have to actually, if I give you my subgraph, you have to also work with that.
Yeah, I mean, I see your point, but the expectation is only the same ordering. So from the keys to the output.
It doesn't mean that you, like, let's say, I think this also could work, because if we have the key here,
yeah,
we could fetch the key, and then we could check the results. Like we don't have to return necessarily the same amount of entities, right? If we understand the keys.
Yeah.
But these semantics we have to define.
Okay.
And then it's also maybe more efficient depending on how much you fetch.
One thing to keep in mind here is I would love, before we go into detail of this, that we define how do we indicate that a subgraph supports a feature or not, because this could be something that implementations also can prototype. You know, it could be that we have the specification and then 2, 3, 4 implementations start using exactly this pattern with success, then we can add it to the specification. But what should be specified is how do you indicate generically what is supported on a subgraph without a config file, right?
That ties actually in a discussion I had with Derek, where we talked about setting, where a subgraph basically can indicate settings in a generic way.
We need to have this anyway, because think about nullability. Like you could technically plan differently if your gateway is a smart client. But for this you have to know if the downstream service knows about it. And ideally you would do this during
yeah. Okay. We're at the end. Would be great if you have thoughts about that, post it in the Slack channel. We can pick that up again. And next week we can talk about entities.
Sounds good.
Awesome.
See you later.
See you next
See
week.
you later.
Thank you.
Bye-bye.
Bye.